right, so now we're going to see them in action. So how much will be in the account after 5 years with simple interest? So now we have $5,000 and we are working with 6% interest. So we're going to figure out what the interest is, and then we'll add that to the 5,000 for what's in the account. All right, so the interest is going to be the principal amount, which is the 5,000. And then the rate as a decimal, so instead of 6, it's 0.06. And then times the number of years, which they told us in 5 years. So that's $1,500. But the amount in the account after 5 years is going to be the principal plus the interest, which is the 5,000 plus the 1,500 we just calculated. So the account will have 6,500 in it. That's a lot. All right, but let's see how even bigger it gets with compound interest. All right, so now our actual amount, we start with our principal, so that's the same 5,000 times 1 plus the APR as a decimal, 0.06, close, and then that is raised to, so sometimes they put T instead of Y for the number of years. So the book put Y, but other people will put T in the formula, so my apologies for the letters being two different ones. And then this is 5 years. And the caret for raise it to that power. So then instead we get $6,691 and round up 13 cents. So that's how much will be in the account. Or 12, like I never remember which way the bank does it. So still almost $200 more. Now a lot of this is because it's yearly interest, so it's only accruing 5 times. Later, we're going to see what happens when it accrues more. So suppose you invest $1,500 in a savings bond that pays simple interest of 10% per year. How much would you have after 5 years? How much would you have after 5 years if it were compound interest? So, like pretty much the same thing we just did, but with different numbers. So interest is, now it's 1,500. And then the rate is 10%, so that's 0.10, or we could just write 0.1. We don't need the trailing zero, technically. And then 5 years. So that's $750 in interest for 5 years. So the amount in the account will be the 1,500 plus the 750. 750 is half 1,500. Like that's a lot. So 2,250. Now let's see what happens if we do it with the compound interest formula. Then we 1 plus 0.10 to the 5. Why is it doing this? Well, that's irritating. Okay, apparently we need a space. So this is 2415.77. All right. So Not much more, but again, we're not looking at a, now see, here we go. Now we're looking at more accrual periods. So what about 50 years? What about 500 years? You know, this is the kind of thing they talk about in a lot of time travel movies. Well, I'll go back in time and I'll put $1 in this account when the bank opened, and then we'll see how much I have, putting it in some sort of savings account that accrues. So we have 200 in the bank account, paying 3.5% interest compounded yearly. All right. So it's compound interest, so I don't even have to calculate the simple interest formula. That one's boring. All right, so we start with our initial investment of 200 times 1 plus 0.035. Still move it 2 places. And then we're going to raise that to 50 years. That's a lot. So 200 in 50 years becomes 1,116. Now, I'm going to copy that. And put the extra 0 in there through the magic of copy paste. So 5.9048 E9. So the E means times 10 to the 9th, or we're going to move the decimal place 9 times. So this is the same as 5,900, or sorry, 5,904, that's 3 places, then 800, that's 6 places, and then 000. So that is thousands, millions, billions. So 5,904,800,000, roughly. $200 in 500 years. Only with yearly compound interest. So that's a long time. Like, that's way more than somebody lives. So definitely a time machine thing, but that's 500 accrual times. If I start breaking that down into like monthly, then we start getting more accrual periods and we get more interest. And that's what we're going to see on the next page. Our compound interest formula paid N times per year. This they will use as a word though. So I'll pause and do that in the next video.